Hello everyone. This is a presentation about going beyond Elixir and BEAM and integrating with other languages and ecosystems. My name is Mateusz and I am an Elixir developer here at Software Mention, and on a daily basis I work on the membrane framework. So when exactly would we need to use some other tech stack, some other language, or some other tool that is not available in the BEAM directly? Well, basically there are two reasons. The first is performance. So if we need to do some number crunching or some other thing, algorithm that requires cutting-edge performance, possibly it's better to do that in some low-level language than in BEAM-based language. Or if we have some tool or library that is not available in BEAM and we'd like to use it anyways, then integration comes into play. So in this presentation, I'd like to show some ways or options that are available to achieve that. I won't be going deep into details because this is quite a widespread area. So let's start. The most popular, I think, and really also performant way to bridge Elixir or Erlang with another language is our NIFs, or native implemented functions. So these are basically callbacks that you implement in C and that the BEAM calls, and you define it with help of our NIF library. Then you need to build that code and link that to BEAM dynamically via SO shared object or DLL, and then the BEAM will call the callbacks you implemented, and hopefully that will work. So the NIF library that we need to use to achieve that is quite powerful. You can do a lot of things, even send a message or monitor a process from C, but it's also quite hard to use and requires a lot of boilerplate. Also, it doesn't provide any build system, and of course, so that you need to compile everything on your own. And of course, it requires using C, which may be not the language you want. So let's see how it looks like. Here I have a demo. So here's how we implement a simple function that adds two numbers with our NIF library. So here we create header. It looks a bit like a main function because of argc and argv arguments, and then we need to get those arguments and then create a proper result. Also, the boilerplate that is needed to make that all work. Let's see how it performs. So we have this merger, we can do add and pass some numbers. Seems working. However, if we do something like this, so we pass float, then it doesn't work and it doesn't crash, it just returns wrong result. Let's see why that happens. Basically, here we assume that the arguments passed are integers. If they are not, then something will be retrieved, and we will need to operate on that pretty much unpredictable value. So if we wanted to verify actually the arguments here, we would need another piece of boilerplate. Also, we need to create a module that defines all these functions that we want to bridge into C, but they rise by default. That's because they are actually overridden when the native code is loaded. So that's oh, and we also need to add quite something to mix.xs file, because as I mentioned, the native code doesn't get compiled out of the box. So we need to define another override actually the compilers option in mix project, and run make, and also create, of course, a make file that will compile the native code for us. So that's pretty tough. What can we do to avoid writing this boilerplate and this tough code to avoid using our NIF basically directly? Well, we can use Rust, which has a Rustler tool. And this is, as you probably know, a modern language which has a pretty decent standard library. Instead, not like C. It's also quite safe. I mean, it's way harder to get a segfault, for example. And there is a Rustler which provides interoperability between Rust and BEAM. Let's see how we can use it. Here we have another demo. So basically, maybe let's start as we did from the native part. Basically, we have to create a function, a Rust function within a Rust project that does what we need to do. So here it also adds 2 numbers, and we need to register that function with Rustler in it. We also need some boilerplate on the Elixir side, pretty much similar to the R NIF version, but here we just do use Rustler and passed some arguments. So let me show you how it works. It's not here. And if we pass wrong argument, it will throw an argument error. So we don't have the problem with unverified arguments. All that is quite concise, and we don't need to create override compilers and add this that much boilerplate as in case of our NIF. So looks quite great. Let's see what are other advantages of Rustler. Well, it works well. It's quite popular. We use it in Membrane as well, and it works great for us. It can be used from Erlang, not only from Elixir. It supports precompilation, so that you can distribute precompiled artifacts and not require everyone to use to have the compiler installed and compile all the Rust artifacts along with Erlang or Elixir. However, if we need to call a C library or C++ library, it's not really that convenient because basically all the Rust benefits, all the Rust guarantees that it gives don't work when calling C or C++ code. While using Rust, we actually have not a one bridge between 2 ecosystems, but actually 2 bridges. The first between BEAM and Rust, and the second with BEAM and C or C++. So we have additional language only to call the C or C++ function, which is pretty much overhead. And we're not using Rust potential. So in that case, there are better options out there, and one of them is Zig. And Zig is a language that was created to be a bridge between various languages and C. It provides a build system and ships with a C compiler, so that you can compile, build everything with a single tool. Zig has also a reasonable standard library, which again is not present in C. And there is a Ziggler tool that allows interoperability between BEAM and Zig. Let's see how it works. So here I have an example. We do use Zig, and then we use sigil-z to create a NIF function that's written in Zig, and basically that's all. So it's really simple. If you don't want to use this sigil, you can do something like sources and path to the file with the source code. So for longer stuff, it's, I think, better. Also, if you need to call, for example, C, here I have another demo from Zig. It's pretty easy. You just specify the library here, and then do this include thing, and then you can just type blast.cblast.dexpy in this case, because we imported blast here in the line 8. So again, pretty simple and straightforward to use. The problem with Zig is that we still have another language. It's quite suitable in this case, but still is another language, and moreover, it's in beta. So this is another thing that you have to rely on in your project. Also, it doesn't support Windows, and it's meant to be it's meant to interoperate with C. So calling some sophisticated C++ API maybe not that straightforward. And another tool that allows interoperability using NIFs is Unifex, that we created in Membrane, and it only requires you to write C and C++, actually the one you prefer, and it provides a DSL that is similar to Elixir type specs. So let me show you. In case of Unifex, you need to explicitly create this interface, as I mentioned, with this syntax. This is the add function that, again, accepts 2 integers and returns an integer, and a C file that implements this function and accepts additionally Unifex environment that is helpful in some cases. And another thing you need to do is to create a Bandex project which specifies sources, and here you can also add some libraries, and the preprocessor of Unifex means that we use Unifex because we can use the Bandex build system alone as well. And basically that's it. So let me see if that works. Seems it works. So as you can see, Unifex is not that simple, not as simple as Ziegler to use, or maybe it's not that easy to create some new project. But since you have that, it's pretty easy to operate with. And Unifex doesn't require you to write anything beyond C or C++. But it also doesn't provide any features that are not provided in C or C++, so it's that trade-off. As I showed, it provides a simple build system that's called Bandex, and it's already 1.0, so that it has a stable API, while Ziegler and Rustler are still in beta. Well, as you can see, there are many options to work with NIFs. However, even though they overcome some limitations of NIFs, there are problems that cannot be that simply overcome, and the end user has to deal with them. The first one is that crashing a NIF that crashes can crash the whole Beam instance. And for example, if you have a segfault this happens within a NIF that runs within a Beam instance, the whole Beam instance will crash. Another problem is that long-running NIFs have to be specially treated. That's because Erlang scheduler cannot take control over the native code, so all other processes waiting to be executed with this scheduler will have to wait, and all the soft real-time guarantees of Erlang won't be held. So that's why we have to especially care about that the NIFs that may run longer than approximately 1 millisecond. Also, NIFs, even though they are pretty fast to execute, and they're actually the fastest option out there, they have some overhead, so that for example, a NIF that does only a couple of instructions and returns may not be more performant than the same code written in Elixir, because the overhead of executing that NIF will be too high. So in case of optimizing performance, we have to find balance between the short and long-running NIFs. So these are the ways that you can deal with long-running NIFs. I won't get into details here, but if there's a chance that your NIF will run more than 1 millisecond, then definitely check out these options, for example, in the documentation for the rNIF library, and pick one that's best for you. To avoid the Beam crashes, we cannot just use any technique like that. The only way is to have a separate Beam node that will execute our NIF, and then if the NIF crashes, that node crashes and our main node won't crash. That's some option. However, in that case, it's usually better to use something that I called beamless node, which is a node that isn't actually a Beam instance, but it can connect to the Erlang distribution cluster. So here we basically leave the area of NIFs. If you don't want a bug in your native code crash the whole Beam, then just don't use them. So as I mentioned, beamless nodes don't require Beam, but they still can connect to an Erlang cluster. They basically communicate like any other node, and they are usually written in C, so that's why they're referred to as C nodes. To create a C node, we need to use our interface library, which basically is split into two files, EI connect and EI, and there used to be also our interface file, while EI stands for Err interface. It was quite confusing, but fortunately the Err interface is no more. It was removed in OTP 23, but still some resources point to that, so be careful and make sure to use up-to-date resources, because that can be quite misleading. This way, like this library Err interface or EI is also not very straightforward to use, and actually it took us quite a lot to make that work. That's why we also incorporated that functionality into Unifex, so that with Unifex you can actually use both NIFs or C nodes, or you can use what's more suitable. Let me show you. So here we have interface in bandex.xs file. We can also have a C node here. And basically this is it. We don't need to do anything else. We still can use this same code, but started via C-Node. So let me show you how it works. We can still do Unifex demo add, and it will work. However, we can do Unifex C-Node start, or starting. Here is the name of application, and the name of the C-Node, which happens to be the same in this demo. And then we can do Unifex C-Node call. Function and arguments, and it still works. What's interesting about C-Nodes is that they don't crash the whole beam if they fail. So if we write a segfault here, let's run it again. We have an error, but the beam is still working. We can do still working. However, if we do Unifex demo.add, which uses a NIF implementation, we have a segmentation fault of the whole beam instance. Indeed, lightweight nodes or beamless nodes or C nodes don't crash the whole beam when they fail. However, that comes with the cost of way bigger overhead. Also, it requires the distribution, Erlang distribution, to be run, and this is sometimes problematic because, for example, EI Connect library doesn't handle IPv6. So especially if you have already some specific distribution setup, or you have some specific environment that doesn't support IPv4, for example, then it might be problematic. For the rescue, we have ports. So ports are separate operating system processes, just like C nodes. However, they communicate over standard I/O. We have a port module to communicate with ports, and for example, system.cmd uses ports to spawn commands. So basically, we have a similar overhead with ports, just like with C nodes. Here we have another problem that potentially we can just spawn some programs that we didn't write, but some third-party programs directly with ports. And depending on how these programs are written, that may have some that may make some trouble. However, if you prepare your program properly, that should work without problems. Also, ports don't have built-in support for Erlang terms, so that you cannot just send some Erlang term to port, you have to serialize it. As I mentioned, there are problems with third-party programs used as ports. Basically, there are two main problems. One is the zombie processes that may remain if the communication channel between beam and port is closed improperly, and they don't have back pressure, so you have to control the stream of data that is created between that port and beam instance, not to flood either the port or the beam. So here are libraries that support that make it easier to work with ports, especially third-party ports. And here, this table also shows what features they have and what problems they avoid. Is always a kind of trade-off. If you are to use third-party program support, then definitely check out these libraries and pick the one that's most suitable for you. As I also mentioned that ports require manual serialization of data sent to them. Fortunately, we have a thing that's called external term format that is a binary format for serializing Erlang terms, and that's provided by OTP, so that you can do Erlang term to binary or Erlang binary to term. And you have either a binary representation of the term or the term retrieved from a binary. So this is exactly used by Erlang distribution as well. So we can just use that and not add another method of serialization. For example, Erlang interface works with Erlang term format, the same that I mentioned that is needed to work with C nodes. And there is also Erlpack library by Discord that adds support for external term format to JavaScript, Python, and Go. Regarding ports, there used to be, or there actually still exists, a thing that is called port drivers. This was something between NIFs or ports, like in short, but it seems it's no longer. I asked on Erlang forum because it's not directly deprecated. However, the guy from Erlang core team answered that we should use NIFs because port drivers are going to be removed at some point. And the last thing I'd like to mention is LUARL. It's another way of interoperability, of having interoperability between BEAM and some language. In this case, it's an interpreter of Lua written in Erlang, so we can just execute Lua code by calling this interpreter that we already can have in Erlang via this library. This is really useful for executing code that should be sandboxed because it's, for example, untrusted, and we'd like to add like support this way of interaction so that user can specify via code what needs to happen. At this same point, we don't need to worry that this code will be malicious or will break something because it's securely evaluated by this sandbox interpreter. So that's all I prepared for today. Here is the repo with all the code I presented and a bunch of links that will be helpful, I think, when you will deal with interoperability via BEAM. And that's all. Thanks a lot.